Okay, now we are going to see solving two simultaneous equations of two unknowns using the matrix method. It's a common method, so we are going to see how to go through it. We have seen how to solve simultaneous equations of two unknowns in different ways, and now I'm giving another example here. So the solution is going always to be very fast. The solution here is you start by creating what we call a coefficient matrix. So in my solution here, what I do, I come for my solution. The equations are 2x minus y equaling 5, and then 3x plus 2y equals 4. So start by picking out coefficients in the order. This should be x, then y, then these are what we call the solutions. So to do that, we pick now the coefficients of x. So I pick 2, 3. Then I come for the coefficients of y. You see this is -1 and then a 2. Then in that order of x, y equals to the solution. This is our solution. So this is what we call the solution matrix 5, 4. And then from there, the idea, the technique is what we do, we get a determinant of this matrix. So if I get this matrix here, you see it's 2, -1, 3, 2. If I'm to get a determinant of this matrix, the determinant now will be, we get the 2 times 2 minus 3 times -3. How we get a determinant? We say we get the product of the elements in the major diagonal. This is what we call the major diagonal. Then times the product of elements in the minor diagonal. And this, you see that this one is going to give us a 7. Or this will be -3 minus plus this 4 to get a 7. Now what we do, we get also what we call the adjoint. So our adjoint of that matrix, the coefficient matrix, is going to be, we said we interchange elements in the major. So this one becomes 2. You saw when I interchange 2, it goes there and then, but it's the same. And then also we said we multiply elements in the minor. This is what we call the minor diagonal. This is what we call the minor diagonal. So I multiply a negative with elements in the minor, a -1. So if I multiply a -1, I get -3. If I multiply a -1, I get a 1. That's the adjoint. Now what we do, we multiply this adjoint first on the left and also on the right. So what I do, I'm going to put now there my adjoint, but first. So if I put my adjoint here is 2, 1, -3, 2. I multiply this side first, but remember I'm multiplying it here, but here initially I had 2, -1, 3, 2 into x, y equaling 2. I multiply the adjoint first, which is 2, 1, -3, and then my 2. Then I come and I put this here, which is 5, 4. What we are doing is we get the adjoint, we multiply it first this side and also this side. Now here we come to what we call matrix multiplication. We say row by column. But the easiest technique there is, if you get the adjoint and multiply it with the matrix which gave you that adjoint, it means that you are going to get a matrix of order 2 by 2. So this matrix is going to be order 2 by 2. Because this is 2 and this is 2. So this I'm going to get the matrix. What we do, always the determinant of this matrix we use to get the adjoint is always going to be, we are going to have only in this major diagonal, we are going to have the determinant of the matrix we use to get this adjoint O. So this one now, when we multiply, this will give you 7 and this will give you 7. Why? Because when I get the determinant of this matrix, I get 7. Or you can go row by column. This will be this times this, that will be 4, this times this, which is 7 after adding. So always in the minor, always this is going to give us a 0, 0. As simple as that. So to save your time, you always get the determinant of this matrix. When you multiply the adjoint and then the matrix used to get the adjoint, you are going to get always the determinant as the entries as the entry as the only entry in the major diagonal, then 0 in the minor diagonal. So the whole of that is simplified to that xy equaling 2. Now here we use this one is a 2 by 2, this one is 2 by 1, meaning they are able to multiply, and then the resulting matrix is going to be of order 2 by 1. So this times this, you see this is going to be 10 plus 1 times 4, and that will give us 14. Then this times this, negative 15 plus 2 times 8, which would be a positive 8. So negative 15 plus 8, that gives us negative 7. And so here I end with my negative 7. And so if you multiply this times this, you see we have this times this, we have 7x plus 0. Then this time this is 0 plus this times this, which is 7y equaling to 14 negative. And we said if two matrices are equal, it means that their corresponding entries are equal. So I mean this is equal to this. So now my 7x will be equaling to a 14, and 7y will be equaling to negative 7. And from here you can start my x becomes 2, and here my y becomes a negative 1. So this is not or, this is and. And so we have solved those two simultaneous equations with ease. So that's the idea of solving two simultaneous equations using matrix method, as simple as that. That's it, members. Don't forget to subscribe to the channel. It's Teacher Kabuzi Math. That's my contact. I wish you well. We are going to see more equation. Now this was a number which was dealing with solving simultaneous equation using matrix method. But we said you can use substitution, you can use elimination, you can use graphical method. There are many depending on the choice, but this one is so common. See you soon.